These are the video notes to help get you started on the graph and quadratic functions in Vertex form homework assignment. So I'm going to do one problem in each section. So from this first section, we need to do a couple of things. We're going to describe the transformation, complete a table, and graph the functions. So let's pick a problem to get started with. Maybe, I don't know, let's look at something that's a little bit challenging maybe. How about number 5? So we have g of x equals 2 times the quantity x minus 1 squared minus 6. All right, so let's talk about the transformations. That's the first thing we have to identify. So the 2 out front means we have a vertical stretch by 2. We have x minus 1, think opposite h, so we're going to say go right 1. And then keep your k as is, it's a negative 6, so that means we're going to go down 6. So here's the 3 transformations that are occurring here. Now let's go ahead and complete our table. So one of the things I want you to notice is this 2 is positive. So since it's positive, it means our graph will open up or concave up. Because it concaves up or it opens upward, that means that it's going to have a minimum point. So our vertex will be a minimum point. Now, for the axis of symmetry, the formula is x equals h. So it's actually a line represented by x equals the h value. So in this case, think opposite h. So it's going to be positive 1, not negative 1. So x equals 1 is our axis of symmetry. So to find our vertex, we use the h and the k. So it's going to be 1 and negative k. So we're getting that information right from the equation. We don't have to do any work to solve for that. Then we know that in this case it's a minimum value because the graph opens up. So I'll go ahead and circle minimum, although you can skip that piece. But we need to know the value. And the value, whether it's a minimum or a maximum value, it's always going to be k. So in this case, it's going to be negative 6. So these numbers should always be the same, just like these numbers are always going to be the same. Now to find your y-intercept. Your y-intercept is where where x equals 0. So going back to the original equation, we're going to take out everywhere we see an x and replace it with a 0. So it'll be g of 0 equals 2 times 0 minus 1 squared minus 6. Well, 0 minus 1 is negative 1. Negative 1 squared is a positive 1. 2 times 1 is 2, so 2 minus 6 is negative 4. So when x equals 0, we get a y value of negative 4, and this represents the y-intercept. Notice I'm writing it as an ordered pair. You should try to do that, please. The domain, remember, we said the graph is going to open upward, and the arrows will not just point up, but they'll also point slightly to the left and slightly to the right. So the domain is going to be negative infinity to positive infinity. The range is going to be, remember what our k value is, negative 6. Negative 6 is our starting point. And then because it opens upwards, all the other y values will be greater than negative 6. So negative 6 is actually our lowest point. That's why it's our minimum. Brackets around negative 6. And then remember, parentheses always around the infinity symbols. Now, I put just the infinity symbol here. You could have wrote positive infinity or just infinity. Either one of these signify positive infinity. So either way is fine to write. Now, let's talk for a minute. When we go to graph these, we have 1 and negative 6. That's my vertex, so that's way down here. And I have another point, my y-intercept, which is at 0, 4. So I can go ahead and reflect this point across the axis of symmetry, which should be, let me go ahead and draw that in right here. So if I have a point 1 square to the left, then I'm going to have another point 1 square to the right from the axis of symmetry. And we just need to graph a couple more points. So I'm going to go ahead and take x and y and make modifications based on our transformations. So a vertical stretch by 2, that changes the y values. Going to the right affects the x values, and going down affects the y values. So unless we're going left or right, everything else has an impact on the y values. So because we're going to the right one, we're going to write x plus 1 here. Also, you can look at this as this equation should be the opposite of this equation. So if this is x minus 1, you're going to write x plus 1 down here. We're going to take our parent points, 0, 1, and 2. And we're going to add 1 to each of those, and we'll get 1, 2, 3. Over here, we've got a vertical stretch by 2, so we're going to take the y values, multiply each one of them by 2, and because we're going down 6, we're going to subtract 6. So remember your parent points are 0, 1, and 4. Remember how we get those? I'm just squaring each of these numbers. So I'm going to multiply 2 by each of these numbers and then subtract 6. So it'll be 2 times 0 minus 6 equals a negative 6. That's the vertex. And that first point should be the same point that we already listed here in our table over here and that we're graphed over here. The next point is going to be 2 times 1 is 2, minus 6 will give us a negative 4. So 2 and negative 4. And again, that point is actually the point that we graphed that was symmetric to the y-intercept up here. So we've got one more point to graph. In this case, I've got 2 times 4 is 8. 8 minus 6 is 2. So my very last point is going to be 3, 2. So come over to the x-axis, find 3, and then again run my pencil up to the 2 value, put a point there. That happens to be 2 squares or 2 units to the right of the axis of symmetry, so I just have to graph another point 2 squares to the, or 2 units to the left of the axis of symmetry. I've graphed 5 points, so I'm good to go, and I am done. All right, so now let's go to the next section. Ooh, okay, right here it says describe the transformation of f of x equals x squared represented by the graph. So we're going to describe the transformation, identify the vertex, and then write an equation that represents g of x, or the transformed equation. So, ooh, let's try number 9. Number 9 looks interesting because the graph happens to be wider. So first thing we have to do is identify the transformation. So again, RDT, RDT, RDT. I can't stress that enough. Let's check if there's a reflection, a dilation, and then a translation. So the graph is opening upwards, so there's no reflection. It's definitely wider. It looks at least like it's wider than it should be. So there's going to be probably a vertical shrink or compression, but we have to determine by how much. And then I also noticed while the graph didn't go left or right from the origin, it did go down. So it went down 2. So we have a transformation where we're going down 2 and then a vertical shrink or compress, however you want to write it, but let's try to figure out how much. So when I look at this graph, one of the things I expect is to be able to go to the left or right 1 square from the vertex and go up 1 square. And I should have another point on the graph, but I don't. This graph is actually wider than what I expect it to be. That's what tells us it's a vertical shrink or vertical compress. The question becomes how much. Now I can't use the 1-to-1 ratio because the actual graph cuts right through the middle of a square, so that's not useful information. So let's try to go out 2 squares to the left, or you can go 2 squares to the right. It really doesn't matter. The same thing should happen. We know the formula is that when x equals 2, y actually represents x squared, and that should be 4, right? 2 times 2 is 4. So we expect to go to the left or right 2 and go up 1, 2, 3, 4. But we know that that's not going to be the case because this graph is wider. Instead of going up 4, if we count to the left 2, we only have to go up 1 unit or 1 square before we hit the graph. So that means that instead of having a 2 and a 4 here, this is going to be 2 and 1. So when x equals 2, you just go up 1. So the 1 is going to replace the 4. So here comes the question. 4 times what is going to give me 1? You've got to solve that problem. Well, all you're doing here, think of this as not just 4, but 4 over 1. In order to get this to equal 1, all I do is multiply it by its reciprocal or its multiplicative inverse. So 4 over 1 becomes 1 over 4. So this is a vertical shrink by 1/4. Last but not least, I need to write the equation. So g of x equals, there's no reflection, so I don't have to worry about a negative. We're going to do 1/4 times x squared. Notice that x is not in parentheses, and that's because we're not shifting the graph left or right, so I don't need to put anything inside the parentheses. And we're going down 2, so I'm going to subtract 2. And that is not in parentheses because remember that affects the y-axis, or in this case, the y-axis happens to be g of x. Okay, so we're done with that problem. Let's do another one. How about right up here, maybe number 14? We have to describe the transformation and identify the vertex. So let's look at what's going on here. So everywhere I see a negative sign or a number, I know that there's a change taking place or a transformation. So I've got 1, 2, 3 transformations. So I tend to read these equations left to right, and I'm going to identify all of the changes. The 2 that's multiplied by the x squared term is a vertical stretch by 2. So that 2 comes from right from here. We're moving the graph or shifting the graph. If it's x plus 4, that means we're going to the left. So left 4, the plus 1 means we're moving the graph up 1. So all 3 transformations are accounted for. The last thing we have to do is identify that vertex, think opposite h, so -4, +1, because we always keep k as is. Okay, and then last but not least, let's do an example of a problem in this section. So we have to write an equation or a rule for g of x, described by the transformation, and identify the vertex if it's not stated already. So let's do one where it's not stated so we get to do all the piece parts. So here we have that we have f of x equals x squared. So this is the parent function, and it's going to be reflected over the x-axis, translated 5 units to the left and 1 unit up. So 3 things are happening here. So that means g of x, which is usually written to signify that this is the transformed equation, equals a negative because it's reflected over the x-axis. Then in parentheses, it's translated 5 units to the left, so you can just write x plus 5, or you could write the formula is x minus, because we're going to the left, it's a -5, but 2 negatives make a positive, so that's why we rewrite it. And then because you're going up 1 unit, it's +1. The vertex, once you have this equation, or you can just do it from here, 5 to the left, 1 unit up would be -5, 1, or again, once you write the equation, it's pretty easy to see opposite h, keep k as is, so -5, 1. That's it. Good luck with your assignment.